This problem reads a dish of hot food has an emissivity of 0.42 and emits 21 watts of thermal radiation. If you wrap it in aluminum foil, which has an emissivity of 0.05, how much power will it radiate? Well, the relevant relationship here is the Stefan Boltzmann law, which says that the radiated power equals the emissivity, how good of a heat absorber and radiator you are, times the Stefan Boltzmann constant times temperature to the fourth power times surface area. So there's a lot of things it depends on, but in this particular problem, we're taking our dish of hot food, and we're going to assume that no matter what we do to it, the food is at the same temperature. All we've done by wrapping it is change the emissivity of that. We haven't done anything to change the Stefan Boltzmann constant, haven't done anything to change the temperature of the food, and we will assume the same exposed surface area for the food. So all of these stay the same. And the question really becomes, when we take our emissivity of 0.42 and knock it down to 0.05, what's that going to do to the radiated power? Well, it's going to decrease it, but by how much? I'm going to take 0.05 and divide it by 0.42 to see, get a handle on what percentage of 0.42 0.05 is. It's about 12%, 0.119. So we have reduced the emissivity to about 12% of what it previously was. That means that we've reduced the radiated power to about 12% of what it was here. So I'm just going to take that same number I have in my calculator and multiply it by the 21 watts of power that used to be radiated and find a new radiated power, which happens to be 2.5 watts. The moral of the story here is something, if you cook it all, you probably already knew. If you have something that is cooling off, wrapping it in something can help keep it warmer longer. I think what's surprising to me when I solve this problem is that I tend to think of aluminum foil as a good heat conductor, and while it is also a pretty low emissivity material, and it can help actually keep food warm because much of the heat that gets absorbed by that foil layer gets re-radiated back into the food.